This is a very experimental demo. I don't know how it'll work out. The idea being just to give an example of eventually using the 4-jaw to turn an off-center pin, shall we say a crank pin, and we've got a piece of scrap really which was pretty rusty, and I've wire brushed it off. What we're going to do initially is face off when the 3-jaw we're running fairly true, and we're going to face off and get a clean surface, get a center marked up, and then we'll take it onto the bench and mark up the center for the crank pin, and then we'll work from there. So let's just bring that in here. We'll back off. Take about a 1/15 thou cut just to get a decent face on it, hopefully. Right, when I took a first cut, we need more. I didn't want to bore you with the whole process of going through all that, so I'm going to try a coarser auto feed, and we'll take another 20 thou cut. Let's see what we got. Okay, we've got a nice smooth face, although the cutting pattern isn't quite consistent, but that doesn't matter too much at the moment. This is all just a demo as against a specific job. Probably a sharper tool bit would help on that. So what we're going to do now is put a center in there and get a reference point. I've just taken a light cut on the outer part there. There's a step section and then a slightly larger diameter. So we're running true with what will be the center. And then we'll proceed to, say, make a small center mark, and then back to the bench and mark up for the rest. We've got a faced surface now. We've got a center made in the lathe. This step and this area, that's been turned down to match the center here. Now let's say, this is all imagination, I mean this is just a demo type thing. 700 thou from the center, I want to have a crank pin, which we'll say is going to be 1/4 inch. So I've measured and I've center popped, and that center pop there is how we're going to get things set up in the 4-jaw. Right, initial setup in the 4-jaw. This is just showing the handle I've described before. This handle goes in the spindle, so it gives me a good opportunity to keep the 4-jaw turning whilst I make adjustments. Now at the moment the wiggler is, as you can see, way off, so what we're going to do is to get a bit closer, and then we can start to dial it in for position, and we'll come back to that. Okay, we're not there yet, but we've got things very close, and there's no point videoing the whole process, but taking it from this stage. Now there's the high point, and then we go low, and we go high, so the lateral is not too bad. But the interesting thing to notice here, which is what makes it problematic, is that in this case, this jaw and this jaw, which is numbers 1 and 3, are not on the center of the workpiece, and this makes it rather difficult for making the adjustments vertically, because we have to allow these to loosen slightly or tighten slightly each time we make a vertical change. Now, to remind you, if you haven't seen other videos, this is a metric dial gauge. Each graduation is 0.01 millimeter, so 2.5 graduations nominally are 1 thou. So at the moment we've got 30, so it's about 12 thou, something like that. So I'm going to carry on here, and there's the high point, there's the low point. So this piece needs to come up. There's the high, so it needs to go down. So this jaw is going to have to loosen slightly and tighten this one, and then these will have to be tightened as we go. So let's see what we can do, get a bit further. Well, after a fair amount of hassle, which you might imagine setting up a piece like this, I pointed out before and I'll mention again, we're so far off centre that even the fore jaw is difficult. You might notice that this jaw, number 1, number 3, I pointed them out before, they are above centre. So each time we want to make an adjustment, we have to slightly loosen these, depending which way we're going. We've got to slightly loosen or tighten these whilst we adjust numbers 2 and 4. And you can't undo any jaw much, otherwise this gets too loose and you have to start over. So to save video time, most people know how to adjust a fore jaw. If you look at the dial gauge, we're pretty close. I'll remind you again, this is metric. We're actually about 1.5 graduations, or probably about half a thou close, just or half a thou off the ideal. And that's half a thou measured there. I can't go much closer because of clearance on the dial gauge. So there may be actually a thou error, which at the moment we're not going to worry about for the approach we're making. And to actually work on this, I'm going to put in the back gear. I don't want to be spinning at about 270 revolutions, I think, on the normal. And the back gear, I'll check that as to what I'm going to get from it. But I've definitely got to rotate slowly here if I'm going to do any machining. Alright, so I'm going to set this up a bit more and set up some tooling, see where we go from there. It's a long time since I've done any significant eccentric turning, and not everybody would necessarily do this the same way I'm doing it, but what I'm planning to do is I have set the cross slide against my little center pop here. I've come back 700, which is my markup for the peripheral position here. I've then wound on 125 plus 25 for the time being. So actually I've wound on 150, so we're leaving a margin of 0.25 for final cuts. The carriage is going to be fed manually. It's going to be a long job. This is really like a very slow fly cutter, pretty much. So there you can see, I hope, maybe just let me zoom in a bit. Right, I've taken the handle out, I'm just turning the chuck. So what you hopefully will see now, if it stays in focus, is there is the center of our crank pin. I'm using a left offset point tool, which is not possibly the ideal, but it's one I'm going to use for this demo run. And you can probably see we're actually 130 thou out from that spot. Now I'm on back gear. One problem I have here is I'm running on an auto transformer, and because I'm on 60 Hz instead of 50, all my speeds are upped. On straight drive I'm running 324 to 2100. On the back gear at 60 Hz, 43 to 240. So I'm going to start this off at 43, the lowest speed, and see where we go with some trial cuts, and then we'll make a little progress and shut the video off, because otherwise it'll get very boring. Oh, I'm just going to set up, this won't be in frame. Let me come back a bit. So I'm going to set, if I can see it, I don't even know whether I'm staying in frame here. Yeah, a pretty wide angle. So I'm going to set the compound, set that up to contact and zero that. Then I'm going to use a carriage stop, which I think I described once before. It's just a block that I keep on the rail down here. So that means then I come back, come up to the stop, and I'm pretty much set for the same point and zero here. So my depth of cut is going to be regulated on the cross slide. I've got it at 90 degrees. I haven't reset it at 30 or 60. This is accurate enough for what I want. So let's come back and crank her up, see what happens. Let's just get a bit of oil around there for a start. This will be a long job, I know that. Zoom in again. Okay, let's leave it there. You can see the beginning of the cut, it's only 5 thou, and we'll get the feed set up, which will save me hand turning it. Right, we got auto feed set up. I forgot to point out, I've got the cross slide, you won't see it now unless I zoom back again. I've got a stop, a lockable stop on the far end of the cross slide, so I set that up earlier for my limit point. We've got the stop on the rail for the carriage, and I've also got a locking down here. You won't see it, there's a locking piece for the carriage. So I should be able to finish this cut now with auto feed. It'll still take quite a while to do. Let's see where we go. Very light cut. This is the first cut of all, so it's very light, just to see how things are working out, and we'll come back when we're making a bit more progress here. Still on the first cut, a bit more progress. It goes without saying, I think, because I didn't mention it before, but running as eccentric as this with a heavy piece, apart from the cutting speed, the excessive revolutions is we got a big imbalance here, no counterweight. And to be fair to the spindle bearings, slow speed is better. The actual progress of the cut is very slow because I'm on a very fine feed on the cross slide, but we're still getting there, and I say this is the first cut. I'm probably running, I speeded up just now, probably took it up to about 150 revolutions plus, and we'll finish this cut off and then set up for a slightly more useful cut. There again, too much cut, not good news, because when we get near the edge here we've got the fly cutter effect where the tooltip impacts the workpiece briefly, cuts and then comes off again. And we're projecting probably 4 inches from the forejaw, so we don't want too much shock effect on the workpiece, although the jaws are done up pretty well. Just a smidgen left, a little bit of crescent right here. We'll just finish that off. Okay, we're clear now. So we've done the whole surface, very fine cut, probably finer than necessary, but as I've said in other videos, I tend to take longer rather than try and rush anything, and this degree of eccentricity necessitates for me fairly slow work. So what I'm going to do now is set up for a more substantial cut, and I'm not going to do the whole project once we've got this started. We'll come back later when we're making more progress, but I'll just show a little bit on the next larger cut. We'll probably put in about 10 or 12 thou. Just one small addition here. I've brought my oil tip over, and I'm just feeding the occasional drop onto the tool. One thing I'd forgotten, of course, I set up the oil drip from the carriage, which wouldn't follow the tool bit. So you can see the red silicon feed tube, and now we're staying with the tool tip. Just the occasional drip, just to keep a bit of oil in that area. Let's finish that second cut. Takes a long time. The feed is only actually giving me about just over 1 thou per revolution, so it's pretty slow going. We're getting a pretty good finish, but it's slow work. Anyway, that gives you an idea of the beginning stage. We're on the fourth cut now, and 15 thousandths again, but the feed rate has been increased to about just over 2 thou per revolution, and we're actually turning faster as well. Well, we're down to depth 170 at the moment. And the crank pin is getting pretty obvious. That's not too bad a finish, although we've been taking a deeper cut, or faster cut I should say, still only 15 thou. We've got a way to go yet. That took, I timed it. It was about 4 or 5 minutes, even at that speed. Right, we're about 240 thou in now. So we're getting there. Not the sort of job if you get impatient. So what we're going to do there is take another cut. We'll get down to fractionally over 1/4 inch. Just taking the, I think I'm going to call this the final cut. This is actually coming out pretty good, although my feed rate is a bit higher than I was originally going to use. So this is going to be my final cut. I'm taking 15 thou again because the finish is coming out pretty good, and I might run the revolutions just a little bit slower, but we've got an oil drip on the go, so we'll probably stick to about the same. So initially, with this saddle unlocked, I'm just going to start a manual feed, and then we'll pull in the auto. Getting near the end of the final cut, so there's not much more to go. There we are, that's actually got to the end quicker than I expected there. So let's assume that's as far as I want to go. We'll check some measurements. And let's try and get this saddle unlocked. Let's see what we get here. Where are we at now? There we are. Let's check again. Alright, let's see where we are. 266. 266. So it's actually 16th hour oversize. I thought it was going to be a bit more than that, but I wasn't very bothered earlier on because I knew I was going to finish it off. So we'll set up for that. Very light last cut possibly here. Just a hand feed. Check that and let's see. Half a thou proud. So I'll just take one more absolute mini cut. I should have had the cross slide angle really to get a more accurate advance, but let's take one more tiny little cut. You won't see much here. Let's come back a bit. I've set the tool post to chamfer. We're exactly 250 on the pin now, so I just took a spring cut. Just going to put a tiny chamfer on. I doubt if it'll even be very visible. You might just see it. Okay. Now the other thing is the length of the pin. So what I've got to do is to check that, decide what I want, and face off a little bit if need be. Although I think actually, when I checked it last, I'm not worried about that centre pop in the middle. That can stay there. So just do another check. I haven't got a depth micrometer, unfortunately, not that I can find. I find the vernier is pretty close. So we're just slightly plus. Actually, correction, I just measured another 3 times, which is a wise thing to do with the vernier, otherwise you won't get a reading that's accurate or that you know is close enough. I just checked, it's actually a thou over. So it's going to stay that way, and we'll assume it's not going to go into a tight fitting crankcase. Let's just imagine this is going to be used on some little steam engine or something with a long throw crank, using this as a long throw crank, and tolerance is not too critical. So now we've got to set this up in the 3-jaw and do the next stage. Correction, when I said 3-jaw just now, I meant 4-jaw, because I want to make sure that this area here is running true. I'm not too worried about that, because that's just rough. So we're high there. Let's just check again. High, low, small increments. Alright, a bit more fiddle, and we're doing pretty good now. As I keep reminding you, this is a metric, 0.01 per graduation, and I would say I've probably got a run out of about 1/4 not even half a bar probably. It's very hard to get this completely still. So there's the 4-jaw setup. Now we'll just do the centre drill. Right, this is just a small number 2 centre drill. I don't want to go too large, don't really need to. Back gear is disconnected, throw in main drive. Auto feed is off. See if that's enough. It may be a bit small, but I've got a good point on the live centre. I think that'll suffice for what we're going to do. Okay, we're going to leave this project here. It's all only meant to be a demo anyway, just a bit of fun to try and do an eccentric turn. So in conclusion, for the time being, in case I may do more later, I don't know, gotta find the time. The live centre's not got a huge bite on it, but there again, we're not projecting far from the chuck. We centred pretty accurately in the 4-jaw. So what we're ready for now, when I've done some dimensions, we'll probably start a cut, probably keep about somewhere between 1/4, 5/16 maybe, and we'll probably come back to about here, remove a whole pile of material, which is going to take quite a while to do anyway, and we'll finish up with something approximating a little crankshaft. But we've made the pin, that was the awkward bit, and I hope you've enjoyed watching. As I said before, I'm sure other people do this sort of operation in different ways that suits them. This is the way I would do it, not having done it for a long time, but interesting to get the old lathe at work again.